All right, Hamza here from ZenML. We're back again with another tutorial, and this time I'm going to be talking about a problem that I keep running across when I talk to users, when I talk to customers in retail, in banking, in finance, in all these different sectors, which is forecasting. Now, this is a very classical machine learning like problem. You take a bunch of data, probably time series, and you try to predict the future time series with it. Think of like sales predictions, order predictions, inventory predictions, stuff like that. The thing is, when teams talk about forecasting, like having to ship a forecasting model, I think a lot of them still are thinking that this means opening up a notebook, running a few cells and forecasting, and maybe scheduling around that. But the problem is that's really not forecasting in production. So in production, in the enterprise especially, forecasting means asking a lot of harder questions, stuff like which model version is actually in production? Why did the forecast shift this week compared to last week? How did we, like if we retrain weekly, is that the right cadence even? Does that make sense for our particular use case? And in order to answer some of those questions, we've come up with a project called FloraCast, which essentially gives you some of the answers to these questions. So I wanted to record a video to walk through that. What is FloraCast? So if you open up the README, this is all open source. You can run it on open source like ZenML as well. FloraCast is an opinionated, production-ready template for time series forecasting built with ZenML and the Darts library. It's less about the model itself. I mean, we're using TFT. You can use ARIMA, you can use Profit or anything else. But really what the focus is on a couple of things. It's about YAML-driven configs. It's about real model versioning. It's about like model promotion and rollback and scheduled retrains and inference. So things that wrap around the model in MLOps that are important. And that's really what I want to talk to you about today. So I want to talk to you about particularly the platform mindset in mature machine learning organizations that you need to have in order to realistically tackle this problem. So let's get right into it. Now, the whole thing boils down and is a bit simplified into two pipelines in this example. One is the training. Imagine this runs weekly. Essentially what you're doing is you're taking a bunch of training data from the database. These could be flat files. These could be directly from a database table, BigQuery or something like that. You do some pre-processing, standard spiel, you train the model. And then the last thing you're doing is you're promoting the version of the model that you just produced. This only happens if the model you just produced weekly is better than the last models. In this case, it's the last week's model, but you can train it across some history and run some benchmarks. This happens automatically. This promotion part is very important because what you're doing is you're storing all your artifacts. Every time you run a machine learning pipeline, a training pipeline, you're using the model control plane concept of ZenML, essentially putting all the artifacts in different versions of the model that you just produced. Then you're selecting one to be put in production. And this is eventually the one that gets picked up maybe on a daily basis, if you're forecasting daily, in the inference pipeline. And the inference pipeline essentially is picking up real data, so live data, ingesting, doing the same pre-processing. That's important. So maybe you have a scalar or something that you have as an artifact that you reuse. So you don't have any train serves queue. And then you're making the final predictions and you're putting them somewhere your downstream team can access. What's important here? The inference pipeline always uses the production model, and puts the predictions back there. So therefore, you know, every time a prediction is made, where was the model which was in production? What were the predictions that we used? Which pipeline was used for it? The training pipeline, on the other hand, is sort of like a data flywheel for you. So you're producing experiments. Maybe you're doing this ad hoc. Maybe you're doing this on a schedule, and you're really producing as many versions as you want, comparing against them, etc., promoting the one that you like in production. So that's what I wanted to showcase here today. Let's walk through the code. The first thing really to look at is the training pipeline. So if you clone this project, it's a ZenML project, so you have it in the ZenML projects repo. You can essentially really like pip install all the requirements, do ZenML login, and once you're set with that, you can open up your pipelines you can see that these are the two pipelines. So in ZenML, of course, the pipeline is decorated with the pipeline function. I've enabled the cache because I don't want to be doing this again and again. If I've already pre-processed it, I don't want to do this, recalculate those. I'm pre-processing the data. I'm actually, doing stuff like training, evaluating. So maybe let's take a look at some of the code here. Pre-processing, this is in the steps. Essentially, I'm getting a data frame, doing some pre-processing using like time series in the Darts library. So for those of you who are familiar, Darts, great library. I think it bundles PyTorch or PyTorch Lightning with it. So you get all those benefits as well. I'm doing some scalar transformations. It's not really important. I mean, this is data scientists would be familiar with what we have here and just returning those. Those go straight into the train model. The train model has all these hyperparameters that are important for me, epoch, stuff like that, and I'm feeding them into the TFT model, doing a train on them, and returning the model eventually. And finally, I'm evaluating, very important, evaluating the results on the test data set, and then again, optionally promoting it. So how does this look like if I actually run it? So in order to do that, I just need to run this command. Both, by the way, means that it will run the training and the inference pipeline. So I'm going to see what happens. So you can see in ZenML, I'm using a local stack here, so it's going to run locally, although save the artifacts in AWS. Oh, everything got cached. And let's take a look at my pipeline. Not this one. Here, this one. So open that up. Here you can see the first 3 steps got cached, so nothing changed because I just ran this before I started recording. And you can see essentially this is visualized. So all the code I just showed you, it's captured here. My artifacts are here. So my time series, if I wanted to visualize that, I can easily visualize it. So you can see with ZenML, you have this artifact visualization concept. I really like that. I can draw my time series out. This can be interactive if I wanted. Some metadata around it, evaluating, and eventually visualizing the evaluation. So I want to see how good my model did, right? So I want to visualize how good my SMAPE was. You can see this is a good score. So this is the predictions. I mean, not good, not bad. But yeah, it's like a 33 SMAP score. So I think that's fine, given the eval data I had. So I can actually, let's see if my model actually got promoted to production or not. If I click here, so this time it skipped production. So you can see my previous score did not get beaten. So actually the same model was being used in production. So this is the model version that was produced. If I click on that, you can see this is not in production. So if I wanted, I could promote this particular model to production. I can always see which pipeline trained this model. I can see the artifacts around it. So I can see the model that's here. So this model is now stored in an S3 bucket. So I can access it anytime. Also my evaluation scores and visualizations, all of these are in one central place. Now, if I went ahead and I saw all the model versions, I can see the one which is in production is right here, right? So I can see number 48. I can see all the pipeline runs associated with it as well. And here I have some batch inference pipelines maybe running on a schedule. But you know what I'm going to do? I'm going to go back to 52 and I'm going to promote this to production. Now imagine in a real setting, what you're doing is you're promoting things either manually or automatically. I mean, most people prefer manual still in 2025 because it's really not easy to decide whether you should do this or not. So in this case, I mean, maybe because of some esoteric reason, I want to promote this particular run. So now the other one got demoted. This one is the one in production. What does that mean? Well, that means that every time I now run the inference pipeline, which I can do by just running the pipeline here, this inference pipeline, you can see, is picking up the production model. So at some point, it's using the get step context, using the context, and using the context to get the train model artifact, right? This is important because what is the context of the model? Well, here I can, in my config file, you can see I'm using the production version. I'm using the production version. So if it's model 48, I'm getting 48. If it's 52, I'm getting 52. And here you can see, if I now see my logs, it's using model version 52, right? I can see that worked. And if I open up my inference pipeline here, you can see this is how it looks like. I have my raw data, I have my predictions, I have my prediction series, so I can actually see what my predictions were. I can put these in a downstream process as well. And again, this is the 52th version. You can see all the tags associated with it, and now I'm back the batch inferences associated with this model. Important is all my predictions are here, so if I run this again and again and again, I can actually always see my predictions here. If I wanted, I can visualize them, sample them, stuff like that, right? So that's really it. What's important here, I think the closing takeaways essentially is it's not about TFT, it's not about the actual model you're using. It's about encoding the best practices that you have that make forecasting reliable in production. So you want to separate training and inference. You want to safely promote and fall back. You want automated schedules. Something I haven't shown you is how to run this in Kubernetes or something like that, or on the cloud. Versioning and lineage, so you have auditability. Those things are very important. So right, that's how you set up such a process. And if you wanted, and this is really the last thing, is in ZenML, if you wanted, you could have different models for warehouses, per warehouse, per country. So if your forecasting problem spans some sort of entity that scale m by n, you can just create different models for each entity. So here you can imagine you have 10 different models per warehouse, per country, per city, and each of those have their own life cycle associated with them. So that's really the platform way of thinking about it. Cool. So I hope this small tutorial helped. Think of it as a starting point for you when you're modeling your own forecasting platform. And if you want to try it out, the repo has everything you need to run the pipelines locally or on your ZenML stack. Thanks for watching.